All right, so this is our last video, and we're going to talk about multiplying polynomials rather than adding or subtracting like we have in the past. And so first we have to remember what a polynomial is. A binomial is, rather. It's a polynomial with two terms. Okay, so when we multiply two binomials, now this is the same example twice. You can double distribute. You can distribute twice, or you can use this box method. So distribute would be down here. It's called FOIL. And this is distribute also, but we're going to use box. Right? When you have something multiplied, something in parentheses, you have to distribute it to everything. So I think that the FOIL way is a pain in the booty, but now that I've learned this, one way to do it is to use a box method, because when you multiply length times width, you're really multiplying to find area. So we're going to use this area model, it's called, and you have to write this down. So I've got x for this box and x for this box. I've got -3 for that box, and I've got 2. And it's kind of like length times width. When you find the area of a box, you do length times width. So this box is x times x, which makes x squared. This box here is x, right? That's x. And that's -3. So that's -3 times x, right? Length times width, -3 times x, -3 times x. Here, it'd be 2 times x. And here, it's 2 times -3, that's -6. And now, we just have to combine all those together. This is really x squared minus 3x plus 2x, because that's positive, right? So it's plus minus 6. Now you combine your like terms right here in the middle. X squared, that's a squared, doesn't look very well, good. Minus 1x, or you could just write minus x, minus 6. Now, I skip that step and go right to these. I notice these are like terms and I combine them together. Right, if you're to find the total area, add all the areas of all the little rectangles together and you get the total amount. So you basically have to multiply, and what you're doing is distributing. And notice, I will show you down here, it's really just FOIL, or excuse me, it's really just distributing. You just have to distribute two things. You have to distribute the 2, which gives you 2 times x, and then minus 6. But you also have to distribute that x. So I'm going to multiply the x times the x. That gives me x squared. And then I have to multiply the x times the -3. That gives me minus 3x. Notice it's exactly the same as this, just rearranged. So I'll get the same answer in the end when I simplify and put it all together. Now you have to choose the method that's right for you, but I'm telling you, for doing unfoiling, factoring it's called, that this top method is everybody's favorite. Also, when people FOIL, they tend to forget one of these 4 terms. Okay, one of these 4 terms tends to get forgotten, and then you've got a wrong answer. So when you distribute, I'm going to use the box method because I find that most students do much better that way. So you make a box. You put your x plus 7, and honestly it doesn't matter if you put it on the top or the bottom. I usually actually switch it, so I'm not sure. This box right here has x times x as its area, so x squared. This one is 7 times x, so 7x. This one is 1 times x, so 1x. And yeah, I do usually write the ones in the boxes. And this last one is 7 times 1, or just 7. So when I put that all together, when I multiply, I get x squared plus 8x plus 7. And that's how it is. So you can, I'm going to skip down here to do this one, example 3. I'm not going to do every example. If you do need more examples, please feel free to go to our notes. They're all written out in the probably last year's in the folder, and you can see them all there. So if you need a few more examples. So I wrote them this way, this one on top and this one on the side. It really doesn't matter. Just be careful with your negatives. So this one, it's -x times -x, which would be positive x squared. Right, a negative times a negative is a positive. And then here, -x times +1 makes -1x, right? A negative times a positive. Here I have a -3 times a -x, so that's again positive 3x. And then this guy right here is -3 times 1. I actually, -3 times 1 is the way I should do that. So it's -3. So when I combine everything, I have x squared, and then I have positive 3x minus 1x. So I'm just going to write plus 2x. That's how I usually do it. I just do it right straight from there. Now, if you are doing something that has a squared, remember, x squared really means x times x. 7 squared means 7 times 7. Z squared means z times z. So when I have x plus 1 squared, it means, oopsie, I don't need my equal sign there. I got a little premature there. It means x plus 1 times x plus 1. So this is x plus 1 and x plus 1. So in this box, you'd have x times x, which is x squared. In this box, you'd have 1x. In that box, you'd have 1x. And in this last box, you have 1 times 1, which is making 1. So all together, you get x squared plus 2x plus 1. When you combine those like terms, that's 2x's. And everything else doesn't combine because they're not like terms. We're going to skip that page. If you need more, you can. We're going to skip area and perimeter examples, but when you get to the point where you want a few of these in your mixed review, you tell me and I'll add them to yours challenge. They really are an application of doing, so we're skipping all these for now. So the last thing we need to talk about is what happens if I have a binomial, right? 1, 2 terms, times a trinomial. That part has 3 terms. Well, I drew my box this way, so I have to make sure I put the 3 terms across and this one going down. Now you could do the 3 going down. You could do 3 boxes going down and 2 across and then do them opposite. It does not matter. Okay, it doesn't matter if you multiply 2 times 3 or 3 times 2, you get the same answer. Same deal with x plus 2 times x squared minus 3x plus 4. Doesn't matter if you multiply one first or the other first. So in this box, I have x times x squared. That makes x to the third for my area, or when I multiply. So on this box, I have x times negative 3x. That's minus 3x squared, right? Because there's an x times an x. So now I have x times x is x squared. This last box is 4 times x, so 4x. This next box down on the bottom is 2 times x squared, so that's 2x squared. This next box right here is 2 and negative 3x. That makes negative 6, right? 2 times negative 3. And then there's 1x involved. There's an x right there, none here. So there's just x to the first power. And then this is 4 times 2. That makes 8. Now put it all together. X to the third. Now I see that there's x squareds right here. That's going to make minus 1x squared because negative 3 positive 2 makes negative 1 when I add. And then I get negative 6x plus 4x. That makes minus 2x plus 8. And that's how you do that. This is the exact same example. You can do that foiling thing, but again, once you get past 2, I really struggle myself to keep it organized, and I lose terms, and I know my students do a ton. So I tend to encourage students to use the box method because it just keeps things more organized. You have to fill in every box, and so you can't forget any terms. All right. I'm going to skip these other examples, but you can go ahead if you need another example to look at. They are certainly in our notes from the previous year, which are the entire packet filled out. I hope that helps, and email me if you have any questions.